Hi students, in the previous video I explained about the first normal form. Now let us see the second normal form. So before going to know about the second normal form, let us see the two concepts. What is a prime attribute and what is a non-prime attribute. So prime attributes are nothing but an attribute which is a part of primary key is called prime attribute. So which is a part of a primary key is prime attribute. Then what about the non-prime attribute? Non-prime attribute. An attribute which is not a part of primary key means this is a non-key attribute. You call it as a non-prime attribute means non-key attribute. The attribute which is not part of primary key is called non-prime attribute. Okay. So let's know about these two concepts, prime attribute and non-prime attribute. Now let us see the requirements of 2NF. First see the requirements. Then we will see what is this 2NF is and how we decompose the 2NF, decompose 2NF table. So requirements is, first, the database is in 1NF. The first step you have to follow is whatever the database, whatever the table you have taken, that table should be in 1NF. Means it follow the 1NF requirements, like the table contains at least one primary key and all the values in the tables should be atomic. And the second is all non-key attributes. So non-key attributes means non-prime attributes. Non-key attributes in table must be functionally dependent on primary key. Okay, so in 1NF you didn't, there is no condition that every attribute should be functionally dependent on the key attribute. But in the 2NF, all non-key attributes in table must be functionally dependent on primary key. So note that we are only dealing with non-key attributes. So in this 2NF, we are dealing with non-key attributes. Those non-key attributes should always depend upon the primary key. So this is the requirements you have to follow. Now let us see the definition of this 2NF. So what is the definition of 2NF? Every non-prime attribute. So I said the non-prime attribute is nothing but an attribute which is not a part of primary key. That is non-prime attribute. Every non-prime attribute should be fully functional dependent on prime attribute if X determines A holds, then there should not be any proper subset Y of X. Means just following the dependency relationship, functional dependence. Every non-key attribute should depend upon the primary key attribute Y of X, for which Y determines A also holds true. Okay. So this is the definition of the 2NF. So here the redundant data across multiple rows of a table must be moved to separate tables. So whenever you are having the redundant multiple rows of a table, that should be moved to separate table. Means you are making to the new table. The resultant table must be related to each other by using some foreign key. Means one table you make it as a primary key. In another table, if you are using that primary key is using in another table, then you make it as a foreign key. Okay, so that is about the rules you have to follow. It means the requirements that you are needed for the 2NF. Now let us see the 2NF decomposition. How we decompose the 2NF. 2NF decomposition. So first is What is the first step you have to? If a data item is fully functional dependent on only a part of primary key, so whatever the data item you have taken that is fully functional dependent on only part of a primary key, then move that data item and part of primary key to a new table. So this is the first step you have to follow while you are decomposing a relation into 2NF. A data item that is fully functionally dependent on only a part of a primary key, then you move that data, what is the data item that is there, along with the part of a primary key into a new table. Now coming to the second step, what is the second step you have to follow for the decomposition? So the second step is if other data item or functional dependent on the same part of key, then place them in a new table. Place them in new table. So third step, make the partial primary key, not fully dependent but partially primary key, copied from original table. So which is copied from original table, the primary key, then make it as the primary key for new table. And next, place all items that appear in the repeating groups in new table. So these are the steps you have to follow if you want to decompose the table into 2NF. So let's see the example for this 2NF second normal form. So here I have taken a table which is not normalized, having the redundant data. So here the student ID is 1, 2, 3 and the names of that student, and ID professor, a professor ID is there, and a professor related to that student is professor name, and their grades they are relating. So this is a table which contains inconsistent data, means it is not clear. So you just decompose the table into normalization. So result after normalizations. So I decompose this table into 3 tables. So which is having a consistent data relating to that table. So related to that table. So first I had taken the student name, student table, a student table consisting of ID and the last name. So 1, 2, 3 and last name. So this table is in 1NF, as well as here the last name is depends upon the ID, means a dependency relationship is there, functional dependent relationship there. So 2NF is nothing but it should be in 1NF, and also it exists a functional dependency relationship. So last name is dependent on ID. Okay, means ID determines the last name. In the same way, ID professor determines the professor. So with the help of the ID of a professor, we can determine who is the professor and who is his name. And coming to grades. So in the grades, why I am saying this second normal form should be fully functionally dependent. I said fully functional dependent. So why it is fully functional dependent? Here the ID student and ID professor and the grade. So a non-key attribute is depend upon the 2 or more keys, then you can say it is a fully functional dependent. Okay. So now these tables are in second normal form. So how I am saying these tables are second normal form? Because here one attributes is depends upon the other attributes, means it is following the functional dependency, as well as the fully functional dependency, means one attributes is depends on the two or more attributes, key attributes, then it is a fully functional dependency. And the same way these three tables are in 1NF also, means no multi values are there, and each table is having at least one primary key. Each table is having at least one primary key. Then you can say this is in 2NF. So let me take another example. So here I am taking, this is a schema. Scheme means it is a relation table. A table consisting of attributes: city, street, house number, house color, city population. So this, now I am making this table as not in normal form. Okay, not normalization. So the keys in this table are, so the keys are, let us take city, street and house numbers. These three are the keys. Now these three keys, all keys determines the house color. All these keys will determines house color. And city determines city population. Means house color depends on these three keys. At the same time city pollution is depends upon city. Okay. So city population does not belong to any key. So this is a non-key attribute. City population does not belong to any key. So city population is functionally dependent on city. Okay. So this is functionally dependent on city, which is a proper subset of the key. Now I am going to make this table as a 2NF. So 2NF means it has to follow 1NF. At the same time it should be fully functionally dependent. So this is a whole schema. A whole schema consisting of the attribute city, street, house number, house color, city population. Just this table. Now coming to new schema, means I am dividing this, decomposing this table into two tables. Two tables. So the first table consisting of street, city, street, house number, house color. So these three are the key attributes and this is a non-key attribute. So this is functionally dependent on these three keys. So this is fully functionally dependent. Means a part of non-prime attribute is depends upon the prime attributes. So this is fully functional dependent. And the same way new scheme is another table. So in this table the city comma city population, because city population is a non-key attribute and this non-key attribute depends upon the city. Okay, so here these tables are in 1NF because each table is having one primary key, 1NF and fully functional dependent. So then you can say this is in 2NF. The two tables are in 2NF. So let's see, this is another example. So this is same I have taken scheme. The table consisting of the attributes studio, movie, budget and studio city. And the keys here is, these two are the keys, studio and movie are the keys. So these two keys determines the budget. Studio determines the city. So this city is not a part of a key. So we can say city is functionally dependent on studio, which is a proper subset of key. Now make this table as 2NF, convert into 2NF. Old table consisting of studio, movie, budget, city. Four attributes are there. Now I am decomposing this table into two tables. So new schema, one table consisting of movie, studio, budget. So movie, studio is nothing but a primary, keys. So this budget is a non-key. Non-key attribute depends upon this two key attributes. So fully functionally dependent. New schema, studio comma city. So this is dependent on this and this should be a primary key. So each table holds one primary key. So these are the rules for this 2NF. So now this old schema is converted into new schema, means in 2NF. This is about the second normal form. Thank you.